Okay guys, here we are on day 3 of trying to get this video done.
Yeah.
Technical difficulties. So, just again, another shortcut here. Just as we had shortcuts for congruent triangles, we have shortcuts for similar triangles. So here's another one. Besides having two angles congruent, we can also have three sides, all three sides, in proportion to each other. And that would make the two triangles similar. So, as long as the proportion is the same, as long as the ratio is the same for all three sides, then we would have the SSS similarity theorem. So if you look at this one, if we compare the small triangle to the large triangle, if we look at the longest side there, the 5 to 10 would reduce to 1 over 2. The side of the triangle is 3, and the other side of the big triangle is 6, and so that reduces to 1 over 2. But if you look at the bottoms, the bottom of the small triangle is 4, bottom of the big triangle is 9, that does not reduce to 1 over 2. And so there's a problem there. It is not the SS similarity theorem like the AA one. You have to have all three sides. And so as that goes through, to where reduce, as we said, reduce to 1/2 and 1/2, but 4 over 9 does not reduce. It doesn't reduce at all, but it doesn't reduce to 1/2 certainly. And so these are not similar to each other. Okay? For the SSS similarity, it has to be all three sides in the same ratio. And you can see that kind of the three-part proportion set up there, showing the smaller triangle to the bigger triangle, that all three of those have to be equal to each other, and they're not in this case. So those are not similar. All right? Anything I missed there?
Yeah, no, just that, like when I teach this all the time, I always notice that the kids will do 2 and they'll be, ooh, 2 of them are right. So it must be similar. Just remember, guys, you got to do all 3.
Yeah.
Take your time and do all 3 to make sure all 3 reduce down to the same ratio. If they don't, they're not similar.
Yeah, so this is a good example for that, because 2 of them were. First 2 that we checked, they were, but the third one wasn't. So, all right.
All right, SAS, similarity theorem. So, we knew sides, SSS was side, 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 so if we put an A in there, it's got to be side, angle, side. And just remember, when we talk about angles in similarity, angles got to be the same and sides have to be proportional. So if you look at this theorem, it's if two sides are proportional and the included angles are congruent, they are similar. Now, notice the important highlighted word there of included. That angle has got to be in between the two sides. Don't forget that. Okay, it's side, angle, side. So make sure it's in between. So if you look at these two triangles, you can see that angle B is a right angle and angle E is a right angle. And BE is, they're trying to make a ratio out of AB to DE and of CB to FE. So if we look at this, we have a 4 to 6 for AB to DE and a 6 to 9 for CB and FE. Just notice that there's 6's on both of these, and the 6's are on opposite triangles, okay, so be careful right there. Now, the way this PowerPoint is going to solve this, guys, is they're going to cross multiply this, and that's going to give it 6 times 6 is 36, or 9 times 4 is 36, so you get 36 equals 36, which works. Or the way I would prefer to do it would be to reduce 4/6 down to 2/3 and reduce 6/9 also down to 2/3, and there you have that ratio that's the same. So you have similar triangles by SAS because they both share that 90-degree angle, and their side ratios are proportional to 2/3. Anything, Mr. Scritch?
No. Again, just the order is critical. It has to be side, the very next angle, and the very next side. They have to be right next to each other. Yeah. Okay, I believe this is our last slide, I think. And so what we need to be able to do here in this example is there's no diagram. And so we're looking at just that similarity statement up there in the corner. And so just like we talked about with congruent triangles, the order of the similarity statement is critical. And so if we're looking at the proportion, the three-sided proportion that they have set up there, they're comparing side ST in the first triangle to one of the sides in the second triangle. Well, the S and the T are the second and third letters, and so you would pick the second and third letters out of the second triangle. And so it should be YZ. So ST is in ratio to YZ. The second part of the proportion has XZ on the bottom. Well, the X is the first letter, the Z is the third letter, or last letter. So we need to pick the same letters in the first triangle, and so that would be R and T. So the numerator in that ratio would be RT. The last part of the proportion is picking the first two letters in the first triangle, RS. So we pick the first two letters in the second triangle, XY, and that becomes the denominator there. So all three of those, if the triangles are similar, like it says that they are, then all three of those ratios are equal to each other. Again, kind of a three-sided proportion set up there. Okay? One more example here, and you need to be able to see the pink triangle here, the top triangle, and the big triangle, the whole triangle, being the brown triangle, the fact that they share that angle up at the top. And so that angle is reflexive. They both share that. And then we need to look at the sides. And you have to be careful with sides here, because the top triangle has the left side being 9, but we can't take 3 being the side of the big triangle. You'd have to add the 9 and the 3 together to get 12. Same thing on the right side. The 6 is the right side of the pink triangle. 8 is the side of the large triangle. You have to add those two sides together. And so as long as those are in a ratio to each other, so 9 is to 12, as 6 is to 8, as long as those reduce to the same thing, which they do, 3 goes into both 9 and 12 3 times and 4 times, 2 goes into both 6 and 8 3 times and 4 times, so they both reduce to 3/4. Therefore, because they share that angle at the top, these two triangles are similar by side angle side. Anything extra there?
No, just that, you see in this slide and 2 slides ago how they're bringing in reflexive angles again, guys, so make sure you can pull out those reflexive angles when they put 2 drawings on top of themselves like they did here. So, just remember, some of these things keep coming back to visit you, so don't just check them off as being done. Remember that they do come back.
Yep. Okay, so that's similar triangles. We'll see you in class.